Welcome to Global Nexus. Please subscribe and hit the bell icon for more breaking updates. Tonight, we're diving into something you use every day but rarely consider: rare earth elements. These 17 metals aren't actually rare, but they're tough and expensive to extract and refine. They're the hidden force behind your smartphone, TV, and computer, essential for high-tech manufacturing worldwide. Without rare earths, the powerful magnets in electric vehicles and the vibrant colors on your screen wouldn't exist. In medicine, they're crucial for MRI machines. In defense, for missile guidance and jet engines. But their most critical role? Semiconductors, the brains of nearly every electronic device. Elements like yttrium are vital for chipmaking, used in protective coatings and high-powered lasers that etch circuits onto silicon wafers. As chips get smaller and more powerful, demand for these pure elements keeps rising, making their supply a global concern. Rare earths are the backbone of our digital age, green energy, and national security. But this deep reliance creates a vulnerability. If the supply is disrupted, the effects ripple across the world. In 2025, that's exactly what happened, sending shockwaves through industries everywhere. The world suddenly realized just how much it depended on these invisible ingredients, and the scramble to secure them had only just begun. How did China come to dominate the rare earth market? It's a story of strategy, investment, and environmental trade-offs. Decades ago, China saw the value in rare earths and poured resources into mining and, crucially, processing them. Other countries, including the US, shut down their own mines, finding it cheaper to import from China. Over time, China built a near monopoly, not just in mining, but in the complex, often polluting refining process. By the early 2020s, China supplied over 90% of the world's processed rare earths, giving it enormous leverage. Western nations, with stricter environmental rules, offshored the pollution and lost their expertise. The world became deeply dependent on China's willingness to supply these materials, a known vulnerability. In 2010, China briefly cut exports to Japan, sending prices soaring, a warning shot the world largely ignored. Despite the risks, global reliance on China only deepened. This set the stage for a much bigger crisis in 2025, one that would threaten the heart of the tech industry. The world was about to pay the price for its complacency. In 2025, the situation exploded. Amid a trade war, China imposed strict export controls on 7 heavy rare earths, vital for high-end tech, especially semiconductors. Companies now needed special licenses to export these materials, creating a bureaucratic choke point. This move followed earlier restrictions on other critical minerals, escalating the standoff with the US. The message was clear: restrict our access to chips, and we'll restrict your access to what makes them. In October, China expanded controls to more rare earths, and even the technology to process them, blocking rivals from building their own supply chains. Even after a brief trade truce, the most damaging restrictions, especially on yttrium, remained. For the global chip industry, hope faded fast. The core of the crisis was untouched, and China's grip on the world's most critical tech ingredients only tightened. The world's technology engine was suddenly running on empty. The consequences would be immediate and severe. China's export controls triggered chaos in global markets. The price of yttrium oxide, essential for semiconductors, soared by over 4,000% in Europe in 2025. While international prices skyrocketed, Chinese manufacturers paid almost the same as before. This created a two-tiered world cheap supply for China, crippling costs for everyone else. Global stockpiles vanished almost overnight. Traders who once held hundreds of tons saw their reserves evaporate. US imports of yttrium from China, 93% of its supply, fell to zero. The supply chain seized up, and manufacturers faced a terrifying new reality: scarcity and uncertainty. Industry experts warned that shortages would soon hit production lines everywhere. The global system of supply and demand was shattered. The world was now facing a full-blown rare earth crisis. Nowhere was the impact felt more than in the Netherlands, home to ASML, the company behind the world's most advanced chip-making machines. ASML's extreme ultraviolet lithography systems rely on rare earths like yttrium for their high-powered lasers. The sudden shortage threatened to halt production, delay deliveries, and disrupt the entire global chip supply. Suppliers across Europe faced soaring costs and empty shelves, threatening to shut down their own production lines. The Dutch and European tech sectors, long reliant on stable global supply chains, were thrown into panic. Industry leaders warned of real choke points and rising costs. The assumption of endless supply was shattered, Western industry now faced a harsh reality. Dependence on China had become a strategic disaster. The scramble for alternatives was on, but time was running out. With crisis at hand, countries raced to break their rare earth dependence on China. The US fast-tracked domestic projects like re-element technologies, aiming to produce hundreds of tons of yttrium oxide, but still far short of demand. Europe, Australia, and Canada launched similar efforts, but rebuilding the supply chain is slow and costly. The real challenge isn't just mining, it's building the complex, environmentally sensitive processing plants China dominates. Some companies are trying to innovate their way out, designing products that use fewer or no rare earths. In India, firms like Simple Energy and Kara Technologies are developing electric motors that sidestep rare earths entirely. But for many high-tech applications, there's still no substitute for rare earths' unique properties. Innovation offers hope for the future, but it won't solve today's shortages. For now, manufacturers are left scrambling for dwindling supplies. The world is learning just how hard it is to replace what China controls. As 2025 draws to a close, the tech industry's future hangs in the balance. China's export controls have triggered a supply shock that shows no sign of ending. Companies like ASML face longer delays, higher costs, and the threat of total shutdowns. If shortages persist, everything from smartphones to medical equipment could slow or stop. The relentless pace of innovation is at risk, and next-gen technologies may be delayed. The era of assuming global trade would always prevail is over. Nations are now racing to secure their own supply chains, prioritizing resilience over efficiency. The race to build new mines and processing plants is now a matter of national security. The world must choose, invest in a resilient future, or risk a prolonged technological Cold War. One thing is clear, the invisible elements powering our world are now impossible to ignore.